Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. So today we will start with new chapter, which is chapter 5, integration. But before we proceed, make sure you have really understood the previous chapters that you've learned. If not, please do so because it will be really convenient and helpful for you to master this chapter. Okay? So anyway, let's begin with our first subtopic, 5.1, integration of functions. At the end of this video, you should be able to define integration as antiderivative and use the basic rules of integration. So, let's recall what you have learned. Let's say I have these two functions over here, which is yx and capital Fx. So when we go through the differentiation process, we will get dy over dx and small fx. Alright, thus these two functions over here is called the derivative of the functions on the left. Now, what happens if we reverse the process? Let's say I want to start from here and I want to get this function over here. This is what we call integration. And the result we get from this process is called the antiderivative. So this function on the left are antiderivative of the functions on the right. So let's go through some definition. A function f is called the antiderivative of function small f if the derivative of capital F is f. In other words, these are the relationship between the derivative denoted as small f and the antiderivative denoted as capital F. Okay, so based on this formula, we know when we integrate derivative, we will get antiderivative, and if we differentiate our antiderivative, we will get our derivative. Alright, so the curly sign over here represents integration symbol, and the prime over here, as you already know, represent the differentiation. Okay? So, let's see some simple example to enhance your understanding. So, let's say we integrate 2x dx and we'll get x to the power of 2. So, based on our formula, we know that our derivative from this equation is 2x and our antiderivative is x to the power of 2. Alright, so example number 2, we differentiate x to the power of 4 divided by 4 and we will get x to the power of 3. So based on our formula, we know that our antiderivative is x to the power of 4 divided by 4 and our derivative from this equation is x to the power of 3. Okay? Now, let's go through 4 basic rules of integration. So, the first one is when we integrate a constant k dx, we will get kx plus c, where c in this case is the constant of integration. Okay? So, let's try some examples. We integrate 2 dx, we will get 2x plus c, and when we integrate negative 5 dx, we should get negative 5x plus c. Okay, so second rule, when we integrate x to the power of n, we will get x to the power of n plus 1 and divided by the power which is n plus 1 and plus our constant. So for example, we have x to the power of 2, so we should get x to the power of 2 plus 1 divided by 2 plus 1 and don't forget our c. So we should get x to the power of 3 over 3 plus c. Same goes as this one, we should get x to the power of 4 plus 1 divided by 4 plus 1 and our c. So we should get x to the power of 5 over 5 plus c. Okay? So moving on to next rule. So we have a constant multiply a function f dx. So we can bring out the constant and we just integrate the functions left. So for example, in this equation, we have negative 3 as our constant, so we can bring out our negative 3. So what's left is x to the power of 3 dx. Okay, so we should get, we integrate, we should get x to the power of 3 plus 1 divided by the power, and don't forget our c. So we should get negative 3 divided by 4 multiply x to the power of 4 plus c. Alright, so let's try one more example. So we have 4 as our constant, so we can bring out our constant. So what's left if 1 is 1 divided by zx dx. So I am very sure that everyone should know what is zx. So zx is x to the power of 1 over 2. So when we bring up, we can write it as x to the power of negative 1 over 2 dx. Alright, so we just integrate that one. So we should get x negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1, and don't forget our c. So we should get 4 x to the power of 1 over 2 divided by 1 over 2 plus c. So 4 divided by half is 8. So x to the power of 1 over 2, we can write it as zx. And don't forget our c. Okay? So this is the last rule. So when we integrate a function plus minus of another function, we can separate the integration. So we should get integrate of the first function plus or minus the integration of the second function. Okay, so let's write some examples. So this one can be written as x dx plus integrate of x to the power of 2 dx. So we can separate these two functions. So this one, we should get x to the power of 1 plus 1 divided by 1 plus 1. So we can plus with x to the power of 2 plus 1, which is integration of this one, 2 plus 1, and don't forget our c. So we should get x to the power of 2 divided by 2 plus x to the power of 3 divided by 3 and plus our c. Okay, so let's try one more example. So we have this first function minus the second function, so we can separate them. We can write it as this one. Okay, so this should get x to the power of 3 over 3 minus 5x, and don't forget our c. So 2 over 3 x to the power of 3 minus 5x plus c. Okay, so these are the basic rules of integration. Now I'll leave you with some simple extra exercises for you to try by your own. So good luck and see you in next video. Bye!